Hello everyone, welcome back to Let's Unbound. So we are in another new episode of AP Precalculus, concept review plus problem solving. And yes, in this video, we will be reviewing the concept of logarithmic function, context and data modeling. And yes, we will solve 3 problems and 1 bonus question for you. So let's get started. As like we did for every function, the main purpose, it has some application, right, in different context. Similarly, we have for logarithmic, there is separate context and data. So some data will best suit for logarithmic function. So how to find that? These are the things in today's topic. Right, so let's get into the video. Logarithmic functions are used in real-world modeling when rapid growth or decay slow over time. So exponential means the function will show the growth or decay. Here, when a rapid growth or a decay, something which is rapid, decay or growth, slows over a time, then this will be applicable because they act inverse, like reverse role of the exponential function, right? So because they are inverse. And it helps model scenarios where change is fast initially and then levels off. This is clearly suggestive like this, right? So there was an increase and it clearly levels off after some time, right? Now, appropriate model for data, we did many regression, linear, quadratic, cubic, like I'd come under polynomial regression, and logarithmic regression, exponential regression. So it depends upon the type of data distribution, type of data and its distribution, and the relationship between variable. Not every data will fit for every, not every model will fit for any data. So there is some point and key features we need to check. And yes, we can make a regression, which is a good fit, right? And now, data style for logarithmic function, how it would be. Logarithmic functions have special patterns. Their independent variables, generally x values. They will not increase by adding the same number each time, not like 1, 2, 3, or 5, 10, 50. They will increase by multiplying the same number. Like it will go like a geometric sequence, like starts from 1, then 3, then 3 times 3, 9, 9 times 3, 27, like that, right? Multiply 3 each time. This is how independent variables will be there. And dependent variables, that will follow the addition pattern. So 3 is your first means 5, 7, 9. So your input values go by multiplication. Your output y values goes by adding something each time. Okay. Now, key observations. So when you see x values are multiplied by a constant number and y values add another constant number, the relationship is logarithmic. Now, logarithmic, the very important thing is the base. So the number you multiply, like if it's multiplying by 3, that the common ratio is there, right? That becomes base of the logarithm. In this example, the independent values are getting multiplied by 3. So the base is 3. And that's it. Let's get into question. Let's see the situation, context, and data of logarithmic function. The population of Austin, Texas is currently 950,000. The population grows continuously according to the model. N of t is n naught e power r t, where n naught is the initial population, or is the continuous growth rate in decimal form, and t is time in years. What will be the population be in 8 years if the current annual growth rate is 3.1%? Question number B. What continuous growth rate would Austin need to reach a population of 1,400,000 in 15 years? Express the answer's percentage rounded to 2 decimal places. Okay. So currently it's 950, so that is initial. So let's make n of t first. N of t is initial value first, 950,000. E is E only. R is growth rate in decimal form. So growth rate for the first one, like we can use like r power t, r and t we can substitute, right? So first case, let's solve. We need to find what will be the population in 8 years. I need to find n of 8. So n of 8 is 950, this is 8, 950,000 e power, or is uh, how much? They say 3.1%, but in percent form, but your R should be in decimal form. So 3% to decimal, what will you do? Divide by 100, move 2 places to the left. It's 0.031 times t is 8 years we are solving for, so it's 8. And we need to evaluate this. This is simpler calculator part. So I will be telling you the answer here. Okay. Okay, here we go. And this, when you use calculator, or you can even use Desmos, that is much more simpler. So you will get something like this. Like you just make f of x and this. So n of 8, when you simplify this part, you will get 1,217,386. Actually, you will get 1,217,386.9, but don't round it up because 0.9 is not a population, right? So that's why we are not doing like that, okay? Not just usual rounding, okay? Now, let's go for B problem. What continuous growth rate would Austin need to reach population of? So expected is this. In 15 years, future value is this. And present value, we know it's 950. But in 15 years, if you want to achieve this much population with this kind of current population, what will be the rate? So R is our unknown, and we need to find R, right? So this is a formula. N of t is 950,000 e power RT. So N of t, I expect 1,400,000 in 15 years. So 950,000 e power R is 0.031, right? No, R is unknown. We are finding what rate? T is in 15 years. So 15R. And we need to just solve it. So divide by 950,000. Cancel up the zeros. 140 by 95. And E comes here, it's ln equal to 15R. So your R is ln 140 over 95 whole divided by 15. So you will get 0.02, again is calculated part, it's approximately 0.02585. But they want this to be growth rated percent, not in decimal form. Very simple, you multiply by 100, it will become here. So it's approximately 2.59%. Always go for 3 decimal place, 3 significant figures. Now question 2. The pH of a solution is given by the formula. Yes, the context of the log. That's why I picked this example. If the hydrogen ion concentration is 3.16 into 10 to the power minus 4, find the pH. pH formula is given. Everything is given, just we need to plug in. And this is without calculator. Okay, no calci. So pH equal to negative log 10 is not needed actually. Just log is enough because it's common log with them, right? So 3.16 into 10 to the power minus 4 without calculator. So minus log when you apply log 3.16 plus, because the product, when you expand it, it will become addition. log 10 power negative. So minus log 10 3.16 means what? Like you can write it as like take log here on both sides, right? So 0.5 log 10 equal to log 10 3.16. So log 10 3.16 is this 0.5. And log means log 10 power minus 4. Minus 4 will come from log 10 is 1. So minus 4. Wait, what? Okay. So 0.5 minus 4. And you take the minus inside, 4 minus 0.5, which is 3.5. Actually, it's approximation. We did the approximation at this place itself, right? So put an approximate symbol at the final point. So this is the pH of the solution. And the last question. The percentage of US adults who own smartphone had increased rapidly since the early 2000s. Table 1 shows the approximate smartphone adoption rate from 2005 to 2023. Observe the table. It started from 2005, then 8, then 11. It's getting added by 3. And smartphone ownership, it's given the values in percentages. Now, what are the questions? Let x represent time in 3-year intervals, starting with x is 1 for the year 2005, 2 for 2008, and so on. Let y represent the corresponding smartphone ownership percentage. Use logarithmic. It's very simple. And B, use your model. We will find the model from Desmos, and then using that, we need to just plug in that also in Desmos. Interpret the meaning of the slope B of your logarithmic regression. So slope is B, like that. That we will get it from the Desmos again while you're doing the first part itself. And we need to interpret with respect to the context of this problem. And also in this problem, we will observe one thing in logarithmic regression. So don't skip it. Do watch the video fully. Okay, first part is I should go to Desmos, right? So let's switch to Desmos. Here we go. So first, you should go for the table and give the table values. That's the first part. Okay. Table. And don't put 2005. We are taking 2005 as 1, right? So 1, 2, 3, 4. Okay, 1 means 2005. 2 doesn't means 2006. It's 2008. 3-year time interval. 5, 6, 1. Okay, like this. And you should copy. While you're copying, make sure you're doing it correctly, because one single thing will completely affect your answer. So it's 95, 70, 58, 48, 41, 81, 88. So actually it's 18 now, so we got something like this. Of course, it doesn't seem like a logarithmic function, but still the question says to find logarithmic regression. So you should give y1. Don't give y. y1 and similar symbol. And then a plus b. Use ln instead log. Ln x. X1 you should give, otherwise what accept x1. And you got your a, b, all of this stuff here. And when you see the scatter plot and our logarithmic doesn't fit actually good, really, right? And I will show how why it is not, and we will justify the answer to here. So first part, A part is here. This is our logarithmic thing. And R squared is 0.09, which is very low. That's why when your R squared is very low, your model will not fit there. We need to look for other model. Maybe I think DK, something like that will work. Right. So we need to write it. So we just take that. Y equal to A is what? 79.387. So it will be 4. Plus B is negative. So negative 8.76 ln x. You can change y to f of x also. So that's it. First part is over here. And next. Use your model to predict the percentage of US adults who will own a smartphone in 2026. So till 2025, 23 7, so 8, when x is 8, like when in 2026, our function will have x is 8. So we are looking for this and very simple substitute in the model equation. Okay, B part. Smartphone percentage on 2026. So we'll find f of okay, if I change as f of x, right? So f of 8 we should find. It's very simple. 79.4 minus 8.76 ln 8. And rest is super easy calculated part. And we will get around 61.2. This many percentage smartphone ownership will be there, right? And okay, we did this part. Interpret the meaning of the slope b of your logarithmic regression. This is a logarithmic regression. How to interpret this? It's negative 8 is negative 8.76, right? So for every 1 unit increase in ln x, the predicted smartphone ownership decreases about. So for every 1 ln x increase, the y is your what? Smartphone ownership. So the smartphone ownership will decrease by 8.76 percentage points. Okay, that's the interpretation for every 1 unit increase in ln x. That's the basic function. The predicted smartphone values. Actually, it's not exact. So use always when you do regression, say predicted word. The predicted smartphone ownership it's decreasing because of the minus, decreasing by 8.76%. Right? So this is the thing. And this regression doesn't fit the data very well because of the model was the R square was 0.0, and that's the one reason. And clearly in scatter graph we can see this is not a reliable model. Right? That's the wrap for we have a bonus question. So take a screenshot of the question, read it well, and solve A, B, and C. You can drop the answers in comment section. Also, you can post your queries, feedback, suggestions. We would love to help you and hear it from you. So that's the wrap for today's lesson, and we will have one more video on lesson content, and then one exam still problem solving will be there. Right? So with this, I'm winding up for today. I will be meeting you next video very soon. Until then, keep learning, keep practicing.